Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is a post Kickstarter campaign video for the Butler. Today I'm going to teach you how to use the relay and how to use the external I/O. And you might think it's external I/O, why do I need a lesson on this? It's not really a lesson, I just want to go over a couple things because you have a few options. So let me zoom in on this corner. So as you can see on the upper right, there is a 6-pin header labeled 5 volts, A, B, C, D, and GD being ground. We've also got a 2-pin header here labeled RLY in, AN11. So that means relay in, and that's connected to analog pin 11. So A11 on the Atmega 2560. So if we want to use a relay, we're just going to use a jumper. Jump this, and we'll control the relay using A11. So in order to do that, we're going to use A11 as an output. So in void setup, we need to use the pin mode command, pin mode A11, comma output, and I'll show you that in a second. I mean, if you've looked at the code, I mean, if you've used Arduino at all in the past, that should be pretty straightforward. You can use any analog pin as a digital pin. So, but by default, A11 and A7, which are used for this output, are analog inputs. So you need to actually declare them as a digital input or digital output if you're going to use them for such case. So we got A, B, C, and D. And A, B, C, and D are actually described right here. So I'll stop the video and I'll reposition the Butler. So here you can actually see the 2-pin jumpers here. This is the AN7 and AN11 jumper. Now we're only going to use these if we want to enable B and D as 3.2 volt outputs. So if we want to use our Atmega 2560 to send a signal through A11 to a Raspberry Pi, and you want a 3.2 volt or 3.3 volt compatible output, what you're going to want to use for AN11, you're going to want to short this header, and you're going to want to connect D to your Raspberry Pi input. If you want to use the AN7 pin and connect to send a 5 volt signal level shifted to 3.2 volts over to the Raspberry Pi, you'd short this 2-pin header and you would use B right here. B. So, as we said before, AN11 controls the relay if you have this pin shorted. So in which case you don't want to have a header on this, and you want to use it as a digital output, and that turns the relay on and off. The relay is active high, so when you have 5 volts on it, the relay turns on, and when you have 0 volts on it, the relay remains off. Now if you're using AN11 or AN7 as an input, either digital input or analog input, like the ADC, you want to make sure that both of these, or whichever one you're using, they're not shorted, because you're adding in a resistor divider which will skew the analog signal coming in. So let's say I have analog pin 7 acting as an input, and I have analog 11 acting as a 3.3 volt output. Then I'll leave this alone. I'll short this pin, if I can manage to do it. And what I'll do is I'll have A connected as my input from an external device, and I'll have D connected to the 3.3 volt compatible output, or whatever the input of the Raspberry Pi. Hopefully that makes sense. So let's talk a little bit about the relay. I've got my multimeter set to continuity mode, which means that if it detects shorts between 2 points, it'll beep. Now I know to many of you this is common sense because you have electronics background, but for those of you who don't have as much of an electronics background, that's what we're looking for here. So what you'll notice is there's 3 pins here. From the left, NC, middle CO, and from the right, NO. So when the relay is off, the CO pin connects to the NC pin internally within the relay. When the relay turns on, the CO pin, the common pin, disconnects from NC and connects to NO. And it will hold it there until the relay turns off. Now, a relay is a high-powered, is essentially an on-off switch, a high-powered on-off switch that's isolated from the electronics on the board, but controlled by the electronics on the board. So you can control AC and DC devices using this. Think of it as literally an on-off switch controlled by electronics. Maybe we'll get to a video of me turning on an AC light. But for now, I just wanted to give you a quick introduction to this section of the circuit. I hope you have a wonderful day, and thanks again for having a look at the Butler. The project page is linked below. Take care of yourselves, everyone.